Welcome to this short demonstration of the digital field screener. The digital field screener is a fully featured visual field screener which runs on a PC or a laptop. It came about as a result of numerous requests from optometrists and ophthalmologists for a portable visual field test which could be used for domiciliary visits and in mobile clinics. Conventional visual field screeners are large and bulky, and the portable visual field tests which are currently available are crude and unreliable. The digital field screener is not designed to replace the well-established clinic-based visual field screeners. It's a screener designed to establish if a patient has a field defect which requires further investigation. In designing the digital field screener, we've had to overcome a number of technical issues. However, by making use of new technology and software techniques, we've been able to rise to the challenge, and we believe we've created a powerful new instrument for the mobile clinician. The digital field screener will run on any PC running Windows 7 or later. It can be used with a single screen, but in practice the test is much easier to administer with a dual screen arrangement. For domiciliaries, mobile tablet monitors are ideal. These connect to a laptop using a USB 3 cable. The test can then be performed on the tablet monitor while the clinician controls the test and records the patient's responses on the laptop. Bedbound or chair-bound patients can even hold the tablet monitor while they perform the test. For this demonstration, we'll assume that the software is being used with dual monitors. A video to show how to use the software with a single screen is also available. The digital field screener can be used with monitors of any size. However, with smaller screens, the fixation target has to be moved in order to present the more eccentric stimuli. This works well, but it does complicate the task somewhat for the patient. Before the digital field screener is used, the screen luminance must be calibrated. This is performed using the spider colorimeter which is included with the software. The sensor is simply placed over the test area on the test screen. The software will then automatically measure the luminance as the screen increments from black to white. This calibration should be repeated on a regular basis to ensure accurate results. Finally, the screen size must be calibrated. To do this, click on the Options tab and then the Calibrate Size button. You then need to measure the size of the screen that the test is running on and enter the screen viewing distance. We normally recommend a viewing distance of 30 centimeters. So you're now ready to start a test. The first stage is to enter the patient's details. To do this, click on Add Patient, and then the compulsory fields are shown with an asterisk. The patient's name will then be added to the top list. To start a test, click on Run Test. Select the name of the person doing the test and then enter the spectacle prescription they will be wearing for the test and their pupil size. Next, select the pattern of stimuli you wish to use. The programs are the same as found on most visual field instruments. The 32 program tests the central 30 degrees, the 24-2 program the central 24 degrees, and the 10-2 program samples a finer matrix in the central 10 degrees. The 32-point program tests 32 points in the central 21 degrees at strategically selected locations. This test is the quickest and is ideal for screening in a domiciliary setting. Next, you can select whether you want to test both eyes or just one. The test mode option allows you to select multiple or single modes. If you select multiple, either 2, 3 or 4 stimuli will be presented simultaneously, and the patient reports how many they can see. If any of the stimuli are not seen, they are then tested one at a time to work out which of the stimuli weren't seen. In single mode, the stimuli are presented one at a time, with the patient simply reporting if the stimulus was seen. In general, multiple stimulus mode is much quicker, but it is rather more demanding for the patient. Finally, you can select a screening or threshold strategy. To explain the difference, I need to quickly explain the test procedure used by the digital field screener. At the beginning of the test, the screener presents either 2, 3 or 4 stimuli in the mid-periphery of the visual field, and the patient has to simply report if they can see any of the stimuli. If they see any of the stimuli, the stimulus luminance is reduced and another pattern presented. If they can't see any of the stimuli, the stimulus luminance is increased. This procedure is repeated following a staircase pattern until the average threshold for the stimuli is found. We call this the working threshold. The test is then run at 5 dB above the working threshold. This means that the patient will only miss a stimulus if their threshold at that location in the visual field is more than 5 dB above the average. If the screening strategy is used, the software simply shows the location of any stimuli not seen at 5 dB above the working threshold. If the threshold strategy is used, the software will increase the luminance of any stimulus that is not seen until it is detected or the program reaches its maximum luminance. In this way, the depth of any scotomas detected can be quantified. So now let's select a 32-point pattern, test the right eye only, and in multiple mode and a screening strategy. If blind spot fixation monitoring is selected, the software will attempt to detect the blind spot. Stimuli will then be presented within the blind spot at random intervals throughout the test. If these are detected, it implies that the patient is not maintaining steady fixation. The number of fixation losses is then presented on the report. If the Show Instructions box is ticked, the instructions to the patient will be displayed on the screen. If Play Sound is ticked, verbal instructions will be given. If Include Demo is ticked, a demonstration phase is included before the main test in order to familiarise the patient with the task. 10-sec delay before starting test, well, does exactly what you'd expect. It gives a 10-second countdown on the screen before starting the test to give the patient time to prepare. Right, we're finally ready to start the test. As we're using 2 screens, a control screen comes up on one screen while the stimuli are presented on the second screen. A demonstration of how to use the program with a single screen is given elsewhere on the website. The patient should now be positioned at the stated viewing distance from the second screen. If possible, the room should be dark or at least dimmed. Do check that there are no reflections on the screen. As with all central field tests, the patient should wear an appropriate refractive correction for the viewing distance. Perimetry lenses or full aperture lenses or even appropriate spectacles can be used, but care should be taken that the frame does not occlude any part of the screen. The patient should have one eye covered with an appropriate occluder. The patient should now be advised that several dots will be flashed on the screen. They must look as steadily as possible at the cross and report if they see any dots flash. To begin with, the dots will be quite bright and should be seen. If they are seen, the screen luminance will be decreased by 2 dB. This process is repeated until the dots are no longer seen. At this stage, the luminance will be increased in 1 dB steps until they are seen again. The luminance is then decreased again. The working threshold is taken as the mean of 3 reversals. Alternatively, the working threshold can be manually selected using the up-down arrows and then selecting Select. The luminance will then be set at 5 dB brighter than the working threshold. The software will then go into test mode. Either 2, 3 or 4 stimuli will be presented and the patient now has to report how many stimuli they can see. If they report the correct number, the stimuli will be shown as green. If they get the number wrong, all the stimuli in that pattern will be shown as red. When all patterns have been presented, any pattern shown in red will be represented in phase 2. If they get the number wrong again, each stimulus will be presented individually to determine which one was missed. Alternatively, the examiner may manually enter the stimuli that were missed by right-clicking on the stimulus and selecting Seen or Unseen. To check, the single stimulus can be presented by clicking on Present. When all stimuli have been presented, the program will return to the main screen and display the results. As this was a screening test, all stimuli that were seen are shown as green, and any that were missed are shown as red. The dB values can be toggled on and off using the Values button, and the report can be toggled between colour and grey levels using the Colour button. A PDF of the report can be created by simply clicking the PDF button and entering a file name. This may then be attached to an electronic record, for example. So I hope that this demonstration has been useful. Please take a look at the other videos on the website to see how to use the program with a single screen and in threshold mode.